In this video, we'll be doing an overview of the periodic table, what it is, more about the groups and periods, the periodicity that it shows, valence electrons, the metals and non-metals and how you actually have the transition across the periodic table, looking at hydrogen and the transition elements, artificial elements, and patterns and trends in the periodic table, particularly with reactivity. The periodic table is a way of classifying the elements. It shows them in order of their proton number. Lithium, for example, has 3 protons, beryllium has 4, and so on. A proton number is the smallest number beside each symbol. When arranged by proton number, the elements show periodicity. Elements with similar properties appear at regular intervals. The similar elements are arranged in columns. Look at the columns numbered 1 to 8 in Roman numerals. The elements in these form families called groups. The rows are called periods. They are numbered 1 to 7. The number of occupied electron shells is equal to the period number. The red heavy zigzag line separates metals from nonmetals, with the nonmetals to the right, except for hydrogen. The group number is the same as the number of outer shell electrons in the atoms, except for helium in group 8. In group 1, the atoms have 1 outer shell electron. In group 2, they have 2, and so on. The outer shell electrons are also called valence electrons, and they are very important. They dictate how an element behaves. So all the elements in a group have similar reactions because they have the same number of valence electrons. As a type of cake called Bakewell tart, which is cake underneath a layer of fondant icing and a cherry. Now, some atoms, like metals, can lose their outer shell electrons very easily, and you can imagine it being relatively easy to prise a cherry off these Bakewell tarts to pop it onto another tart. Now, this is actually what happens inside metals, called metallic bonding. A metal atom becomes a metal ion. It becomes a positively charged ion, and it loses its electrons to another newly formed metallic ion. In turn, your newly formed positive metal ion can take in the electrons that have been lost from another metal atom. Now, in contrast, you can imagine that a noble gas atom has not only the electron that you want to remove, but it also has the other electrons in the same shell. So to remove an electron, you actually need to bring it next to something that's positively charged. And it would take a lot of energy to remove the electron because you have to also overcome the attraction that you have to the other electrons in the full outer shell of the noble gas. In a very similar way, it's very difficult to introduce a brand new electron into the outer shell of a noble gas because it's completely full. The noble gas will not allow any other electrons to come into that outer shell. The electron that you're introducing will not have any attraction towards the nuclei of your noble gas because effectively the outer shell electrons that already exist are screening and shielding the positive charge, so you cannot turn it into a negative ion. So to conclude, the atoms of the group 8 elements have an incredibly stable arrangement of electrons in their outer shells, and that makes them hugely unreactive. They don't want to lose electrons, and they don't wish to gain them either. Now, here are 2 other points about the periodic table. The period number tells you the number of electron shells in the atoms. So in the elements of period 2, the atoms have 2 electron shells. In period 3, they have 3, and so on. Have a look at the table again. Can you see that on the left of the zigzag line, there are metals, and on the right-hand side, there are non-metals? There are actually far more metals than non-metals. In fact, over 80% of the elements are metals. Hydrogen sits alone because it has 1 outer electron and forms a positive ion, H+, like group 1 metals, but unlike them, it's a gas and usually reacts like a non-metal. In the middle of the periodic table, you find a block called transition elements. They're all metals, and you study them later in the course. Some of the elements in the periodic table are artificial. They've been created in the lab. Most of them are in the lowest block, including neptunium to lawrencium in the bottom row. They're radioactive and break down very quickly. As you saw, the elements in a group behave in a similar way, but they also show trends. For example, as you go down group 1, the elements become more reactive, and down group 7, they become less reactive. Across a period, there is another change, a change from metal to non-metal. For example, in period 3, only sodium, magnesium, and aluminium are metals. The rest are non-metals. So if you know where an element is in a periodic table, you can use the patterns and trends to predict how it will behave. I hope you've enjoyed the video. Don't forget to give the video a like and subscribe to our channel for more information on science within GCSE chemistry and beyond. Take care. Bye-bye.